Need to dynamically access configuration files, templates, or assets in your FastMCP tools while keeping your interfaces clean and version-aware. We'll use the context object's precise resource methods to interact with server resources. You'll see how ListResources returns a complete inventory of available resources with metadata including URIs and MIME types, while ReadResource provides versioned access through a list where the current content is always at index 0. The example demonstrates exact URI-based resource addressing, with type-specific accessors like content for binary data, all through the standardized context interface that separates resource definition from consumption.
Hash list available resources. Resources equals awaits CTX. List resources. Hash read a specific resource. Content list equals awaits CTX. Read resource. Resource / config. Content equals content list 0. Content.
This demonstrates the context-based resource access pattern, where FastMCP provides a standardized interface for discovering and consuming registered resources through a request-scoped context object. The pattern uses URI-based addressing with explicit resource types, TextResource, BinaryResource, DirectoryResource, and returns structured resource objects containing metadata like URI, name, description, MIME type, and meta tags. Resources are exposed through two primary operations: ListResources for discovery and ReadResource for content access, with version 2.20 plus supporting custom metadata keys via AddResource. The pattern works by treating resources as first-class server components accessible through the context interface. When listing resources, you receive an array of resource objects, while ReadResource returns a version list where the first element contains current content through type-specific accessors, text for text, content for binary. Directory listings require explicit recursive equals true parameter, and only directory resource types support enumeration behavior. The context handles all serialization and transport concerns, with version 2.9.1 plus automatically sending change notifications when resources are added, enabled, or disabled through the server API. This approach provides predictable access to both static resources and dynamically generated content via resource templates. The separation between resource registration via at MCP, resource decorator or AddResource, and consumption via context methods enables clean component architecture. Resource templates specifically handle dynamic generation through the at MCP, resource decorator, while static resources use direct registration, with all operations maintaining clear versioning and metadata support through the standardized resource object structure. Let's break it down line by line.
Hash list available resources. Resources equals awaits CTX. List resources.
Enumerates all registered resources in the FastMCP context, returning resource objects with URI, MIME type, and metadata tags in the meta field. Each resource supports type-specific accessors. TextResource provides text, while BinaryResource uses content, with directory listings requiring explicit recursive equals true parameter for nested enumeration. The returned list enables version-aware consumption via ReadResource, where index 0 always contains the current content version, with version 2.9.1 plus emitting notifications for add disable operations.
Hash read a specific resource. Content list equals awaits CTX, read resource, resource / config.
This fetches the current version of the config resource from FastMCP's unified resource system, returning a versioned list where index 0 contains the active resource object. The system uses URI-based addressing like resource, // or file, // with explicit recursive equals true required for directory-style listings via DirectoryResource. Resource objects provide type-specific access. TextResource offers text for string content while BinaryResource uses content for raw bytes, with shared metadata, URI, name, MIME type, and optional custom keys via add resource. Static resources are predefined, while at MCP, resource specifically creates resource templates for dynamic content generation, with change notifications, add enable disable available in 291+.
Content equals content list 0. Content.
This accesses the current version's content from the first resource object returned by read resource, resource//config, where index 0 always references the active version in the version list. The resource object provides type-specific accessors, text for TextResource or content for BinaryResource based on the declared MIME type, with URI resolution supporting exact paths only unless recursive equals true is explicitly passed to list resources. Static resources map directly to files, while dynamic content requires explicit resource template definitions via at MCP, resource, decorator, or add resource, with custom metadata keys supported only through add resource since 2.2.0. Resource access pattern. FastMCP's context-based resource system provides unified access to static assets through list resources and read resource, where directory listings require explicit recursive equals true and always return resource objects with metadata including URI, MIME type, and tags in the meta field. The read resource method returns a versioned list with the current content at index 0, exposing type-specific accessors like text for TextResource or content for BinaryResource, while change notifications, since 291+, alert clients only on add enable disable operations, not modifications. Custom storage keys, since 2.2.0+, are exclusively available through add resource, not the at MCP, resource, decorator which targets resource templates specifically.
The empty list that describes every file.